Welcome to the next session on Advanced ANSYS Workbench tutorials. In this session, we will analyze the globe valve for its hydrostatic pressure analysis. We will start by double-clicking on Static Structural module. Next, we will go to Engineering Data and double-click. Then we'll go to Engineering Data Sources. Here we'll click on General Materials. One of the material which is used for globe valve is stainless steel, so I'll select from here. The other two materials I'm going to add, the first one is brass, for which the value of density in kg per meter cube is 8490. Again, we'll click on brass and we'll select isotropic elasticity. Here we'll give the value of Young's modulus, which is 97 gigapascal. So I'll change this unit to gigapascal, and here I'll add the value as 97. Next, we'll give the value of Poisson's ratio, which is 0.31. Also, if you want, you can give the value of tensile yield strength, which is 310 megapascal. So we'll change this to megapascal, and here we'll add the value 310. The value of tensile ultimate strength in megapascal is 469. So once this is done, we will now add the next material, which is bronze, which is another material used for globe valve. So we will give the value of density first. Double click on density, click over here, give the value as 8410 kg per meter cube. Click on bronze once again, go to isotropic elasticity and double click. Here this value of Young's modulus is 138 gigapascal. So change this to gigapascal, 138. Value of Poisson's ratio is 0.42. Again, click on bronze and give the value of tensile yield strength, which is 800 megapascal. So change this to megapascal and here 800. And also give the value of tensile ultimate strength in megapascal. It is 1100. It is 1010 megapascal. So once this is done, we can go to this option. Here we can see three materials have been selected. We will go to project and update project. Once we have added all the materials, then we will right click on geometry and import the geometry of the globe valve. Then I'll go to model and double click. Here we'll first go to geometry and click on this plus sign. We'll select the globe valve and we'll change the material to first stainless steel. We'll go to mesh and update the default size of the mesh. Next, we'll go to static structural A5 and right click, insert, fix support at these two ends. Apply. Again, I'll right click here and insert standard earth gravity. The direction is -z. We'll change it to -y. You can see here this value is shifted to y component and you can see the downward direction. I'll right click here and insert hydrostatic pressure. It is asking for the geometry. So this internal surface is what I'm going to click on. You can press the control button and select it with the mouse. This is done. It's asking for the fluid density. I'll just change this to meter. For water, it is 1000 kg per meter cube. Here, hydrostatic acceleration, I'll change this to component. Along the y-axis, it is 9.81 meter per second square. And I want to give the value of y coordinate for this globe valve. The value of y is 75 mm. Okay, I'll just change the unit to mm once again, and this is 75. So you can see here that is the top portion where you will get the hydrostatic pressure. So inside also you can see the variable hydrostatic pressure has been applied. It will be maximum at the bottom and minimum at the top. Because when the fluid is held in the globe valve and say it is not moving, it is in a static state, then in that situation, this amount of pressure will be exerted. So now I'll go to solution, right click and insert deformation total. I also want to see the deformation directional. You can see it along the x-axis. You may also see the deformation along the y-axis if you want. So I change this to y. Then right click, insert stress equivalent. I also want to see the strain equivalent. Then we'll go to solution and solve. So we'll first go to total deformation. You can see here the maximum deformation is 5.179 into 10 raised to minus 6 mm, which is at the stop zone. You can animate and check this result. Next, we'll go to directional deformation. The highest value is 1.53 into 10 raised to minus 6 mm. Then directional deformation along the y-axis, it is 0 at this end, and here it is minus 5.15 into 10 raised to minus 6 mm. It is 0 here. You can see it is red. And this is negative, hence it is shown in blue. Then we have equivalent stress. Maximum is 0.02 megapascal, again a very less value. And you can see the strain, which is 1.049 into 10 raised to minus 7. So here what you are seeing is the stress strain generated over this body if there is some fluid static in this globe valve. Now let's change the material to brass and see the results. We'll solve once again. Let's click on total deformation. Now the value is 1.12 into 10 raised to minus 5 mm maximum. Then we'll go for directional deformation along x-axis. Maximum is 3.16 into 10 raised to minus 6 mm. Along the y-axis, the maximum is actually 0. Minimum is minus 1.11. Minimum because it is negative. 0 is higher as compared to negative numbers. So again, you will see the maximum is here and these are the minimum values. Now this negative sign obviously is indicating your direction. Stress is 0.021 megapascal, again a very less value, and equivalent elastic strain is 2.23 into 10 raised to minus 7. So this is because of brass, and next we will check because of bronze what happens. We'll first click on total deformation. Maximum is 7.63 into 10 raised to minus 6 mm. Directional deformation along the x-axis. You can see these colors also, they are going to change. It is 2.19 into 10 raised to minus 6 mm. Along y-axis, again these are red 0 and here it is minus 7.6 into 10 raised to minus 6 mm. You can see these values have changed for each material. Stress is 0.0208 megapascal. Strain is 1.527 into 10 raised to minus 7. Now all of them were metals. So somehow you got close values. Had these materials not been metal or some other kind of material, then obviously you would have got quite different results. So with this, I end the session. I hope you have understood the analysis. If you have any doubt, please write to me in the comment section. Don't forget to like, share and subscribe to the channel. Hit the bell icon for latest video updates. See you in the next session. Thank you.